Hi students! Today, you will learn about illustrating the probability of a union and two events. At the end of our discussion, I hope that you will learn to identify the probability of getting an event and analyze the probability of union of two events. Students, are you ready to learn? But before we start, may I ask a question? Have you ever heard the word probability? Or when you hear the word probability, what comes into your mind? Great! So probability is like a chance or what is likely to happen. And very good. We can use it in our daily living. So first, let me discuss what is probability. Probability has something to do with a chance. It is the study of things that might happen or might not. We use it most of the time, usually without thinking of it. And the probability of an event is a number between 0 and 1, where, roughly speaking, 0 indicates impossibility of the event and 1 indicates certainty. To continue our discussion, here is our probability line, wherein you can see here that the probability always exists between 0 and 1. So 0 indicates impossible or might not happen. Even chance is 1/2 chance that it might happen, and 1 is that the event might happen. So let's have an example. Let us give an example. Again, 0 indicates impossibility, 1/2 even chance, and 1 indicates certainty of the event. So in our first picture, you see here a snow. So if I'm going to ask you, what is the possibility that we have a snow in our country, Philippines? So the answer is 0, or might not happen, because we all know that we have two weather only in the Philippines. So this is the sunny weather and the rainy season. Okay, next is, you see here boy or girl, or it is a gender reveal. So if you see a woman carrying or she is pregnant, so the possibility that her baby is a boy or a girl is an even chance, or 1/2. And you see here a student who is responsible and studying. So if he has an exam, so there is a higher percentage that he may pass the exam. So this indicates 1. Let us proceed to our formula. In a sample space, or S, where each outcome is equally probable or equally likely to happen, the probability of an event E, denoted by P of E, is given by P of E is equal to number of favorable outcomes in the event over the total number of possible outcomes in the sample space. In symbols, P of E is equal to N of S over N of E. Let us have an example. 110 grade 10 students of Santa Maria National High School are interviewed if they are willing to join any sport, volleyball or basketball, in the upcoming Sports Fest. Shown here is the result of the survey. So As you can see here in our chart or our table, you see here the sports and the number of students. So in volleyball, we have 22 students. In basketball, we have 44. And in volleyball and basketball, we have 33 students. From that data, we are going to solve these following problems. So, just read the problem, and if you are done reading this problem, you may now proceed to our discussion. You may pause this video for you to read, and after you read, you may now continue watching this video. Okay, class. After you read the questions, let us analyze the given data from our problem. Again, the sports given is the volleyball, basketball, or the number of students who choose volleyball and basketball. So we have here the number of students for volleyball is 22, for basketball 44, and for both sports, for volleyball and basketball, we have here number of students 33. So using our Venn diagram, you see here that in our first circle, 22 for volleyball, letter V of course, to indicate that this is the volleyball. And for letter B, this is for basketball, 44. Number of students, 44. And you see here in the overlapping circles, volleyball and basketball. So we indicate here or write here number 33. And if we add these numbers, this is equal to 22 plus 33 plus 44 is equal to 99 students. However, in our problem, the given students is a total of 110. So, meaning to say, if this is equal to 99, we need to find the missing students. How many missing students? So, 110 minus 99 is equal to 11. So, indicate that the 11 students does not want to join volleyball or basketball. So, we write 11 outside the circle. Again, these 11 students did not choose between the sports volleyball or basketball. So, if we are going to add 22 plus 33 plus 44 plus 11, it is equal to 110, the total number of grade 10 students as it is stated in our problem. So, we are done analyzing and then creating a Venn diagram for our problem. Let us now try to answer letter A. Again, here is our Venn diagram. And the question for letter A is, what is the probability that the students are willing to join volleyball? So just use our formula P of E is equal to N of S over N of E. So this is equal to, just look at our Venn diagram here. You see here the circle for volleyball. So this is equal to 22 plus 33. So 22 plus 33 over 110 because it is the total of grade 10 students. Or again, if we are going to add 22 plus 33 plus 44 plus 11, it is equal to 110. And now we can now simplify. So the answer here is 22 plus 33 is 55 over 110. Just copy the denominator. And again, this is a fraction. So we must always give its lowest term or simplify. So this is equal to 1/2. 55 divided by 55 is 1. And then 110 divided by 55 is 2. So in getting the probability, the answer must, or it is written in fraction form, or in decimal, or in percent form. So if we are going to answer letter A in fraction form, the answer is 1/2. So if we are going to convert it into decimal, the answer is 0.50 or 0.5. Or in percent form, 1/2 is equivalent to 50%. So again, what is the probability that the students are willing to join volleyball? The answer is 50%. Is the probability that students are willing to join volleyball. So I suggest to use the percent in percent form. Okay, let us now move on to problem number 2 or problem B. The question is, what is the probability that the students are willing to join volleyball only? Again, the question is, what is the probability that the students are willing to join volleyball only? You can see here the word only. So again, use the formula P of E is equal to N of S over N of E. So this time, the question is volleyball only. So you will write 22 because the question is volleyball only, 22. Over the total number of students is 110. So just simplify 22 over 110 is equal to 1/5. 22 divided by 22 is 1. 110 divided by 22 is 5. This is in fraction form. And if we are going to write it in decimal, the answer can be 0.20 or 0.2, or in percent form, the answer is 20%. So 20% is the probability that the students are willing to join volleyball only. You see here that it is very easy to answer the questions if after you read the problem, you have to create a Venn diagram for your guide. Okay, let us proceed to answer letter C. The problem is, what is the probability that the students are willing to join basketball? So, use the formula P of E is equal to N of S over N of E. By substitution here, you can see here, willing to join basketball from our Venn diagram. So, it is 33 plus 44 or 44 plus 33 over 110. So add 44 plus 33, 77 over 110. Again, 110 is the total number of grade 10 students according to our problem. This is a fraction. Do not forget to get its lowest term or simplify. So divide it by 11. So the answer is 7 over 10. 7 over 10, or in decimal form, it is 0.70 or 0.7, or in percent form, it is 70%. So the answer is 70% is the probability that the students are willing to join basketball. Percent. Okay, to answer our last question in the problem, I want you to solve it on your own. So the question is, what is the probability that the students are willing to join volleyball or basketball? You may pause this video for a while, and after answering, you may now continue watching this video and let us check if your answer is correct. And then, by substitution, we have here 22 plus 33 plus 44 because based on our problem, students who are willing to join volleyball or basketball. So as you can see here in our Venn diagram, so this is 22 plus 33 plus 44 over 110. So the answer is 99 over 110. Simplify. So divide by 11, 99 divided by 11 is 9, and then 110 divided by 11 is 10. Or in decimal form, it is 0.90 or 0.9. In percent form, it is equal to 90%. So the answer is 90% is the probability that the students are willing to join volleyball or basketball. Let us proceed in illustrating the probability of a union of two events. So the union of events A and B, denoted by A, union B, again this is the symbol for union, consists of all outcomes that are in A or in B or in both A and B. The probability of the union of events A and B, denoted by probability of A union B, so this is the symbol, is equal to the sum of probability of A and the probability of B minus the probability of A and B occurring together, which is called the intersection of A and B and is written as A intersection, this is the symbol for intersection, B. So here is our formula for illustrating the probability of a union of two events. So this is the symbol. P of A union B is equal to P of A plus P of B minus the probability of A intersection B. Let's start with our example number 1. So here is our problem. Enzo rolled a pair die and wished to find the probability that the number that will turn up is even or greater than 3. When a die is rolled, there are 6 possible outcomes in the sample space. So here are the possible outcomes. So we have 1, 2, 3, 4, 5, and 6. So for the probability that the number will turn up is even, so I name it as A. So A is equal to 2, 4, and 6. Even numbers from the possible outcomes when we roll a die. So for B, greater than 3, so this is 4, 5, and 6. And if we are going to get the A intersection B, so the same outcome with A and B, this is 4 and 6. And as you can see here in the right side, we have here a Venn diagram. So this is for A, event A, 2, 4, 6, and for event B, we have 4, 5, and 6. So of course, we write here the number 4 and 6 in the overlapping part of the circle to include that this is the intersection, because again, the 4 and 6, because they have the same elements, 4 and 6. with event A and B. And of course, you see here outside the circle is the number 1 and 3 because it is not included in the event A and B. So this is the result or the possible outcome when we uh, rolled a die. So using our formula, P of A union B is equal to P of A plus P of B minus probability or P of A intersection B. So we have here the probability of event A. This is 3 over 6 because we have here 1, 2, 3. And then the total outcomes is 6 plus P of B. Of course, 1, 2, 3. We have 3 possible outcomes over 6 minus the probability of A intersection B is 4 and 6. So this is 1, 2. So 2 over 6. So first thing that you have to do is to add 3 over 6 plus 3 over 6. So this is similar fraction. So just add the numerator. 3 plus 3 is 6. So this is 6 over 6. So 6 over 6 minus 2 over 6, or 3 plus 3 is equal to 6 minus 2 is equal to 4. Copy denominator because they are similar fractions. They have the same denominator. 4 over 6. Simplify, this is 2/3. So the answer is 2/3. Next, problem number 2. Suppose that in your class of 30 students, 8 students are in the band, 15 students play a sport, and 5 students are both in the band and play a sport. Let A be the event that a student is in band, and let B be the event that a student plays a sport. So first, analyze and then create a Venn diagram. So in here, we have 2 circles to indicate 2 events. For A, this is for student in a band, and B, student plays a sport. So the first thing that you have to do is to write number here in the overlapping circle to indicate the intersection. Okay, so what number it is? So this is 5 students are both in the band and play a sport. So this is the intersection because of the word both. Okay, so 5 students. So just write it 5. Then you may now start filling for the A and event B. So again, A is for the band. So we have 8 students are in the band. So we have 5 already here. So 8 minus 5 is 3. Just write 3 here. And then for B, student plays a sport. So we have here 15 students play a sport. So you have here 5 already. So 15 minus 5 is equal to 10. And then do not forget to add these numbers. 3 plus 5 is 8. Plus 10 is 18. Remember that you have 30 students. So 30 minus 18 is equal to 12. So write 12 in any part outside the circle. So you can write here the number 12. So these 12 students indicate that they do not play a sport or they do not belong to a band. Okay, so let us solve using this formula. Probability of A union B is equal to 3 over 30. So this is for A, plus 5 over 30 plus 10 over 30. So this is similar fractions because they have the same denominator. Just simply add 3 plus 5 is equal to 8 plus 10 is 18. And then copy denominator, which is 30. 18 over 30, simplify, divide it by 2. 18 divided by 2 is 9. 30 divided by 2 is 10. So this is 9 over 10 in fraction form. In decimal form, this is 0.90 or 0.9. And in percent form, this is 90%. Or another solution we have here, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So we have here from our Venn diagram, A is 3 plus 5 is 8 over 10 plus 5 plus 10 is 15 over 30 minus 2A intersection B. So this is the part of the intersection, the overlapping. So this is 5 over 10. So the answer here is 8 plus 15 is 23 over 30 minus 5 over 30. So 23 minus 5. The answer is 18 over 30 or 9 over 10. Or in decimal, this is 0.90 or 0.9. Or in percent, this is 90%. Okay, let us try to solve this. Given the sets below, list down the outcomes of the following. So let's say that we are going to roll a die. So we have here event A. The possible outcome is 1, 2, 3, 4, 5. For B, this is 3. C, 2, 4, 6. And letter D, 1, 3, 5. And for letter E, 1 and 6. So question number 1 is A union B. So first thing that you have to do is to write the possible outcome for A. So this is 1, 2, 3, 4, 5. And then possible outcome for B, this is 3. And then write all the outcomes for A and B. So we have here 1, 2, 3. So you see here that 3 appears twice, but it is the same, so you will write it once. 3, 4, and 5. So when we say union, it is the elements in A and B. Okay, so number 2, C union D. Again, you have to write the elements or the possible outcome of C. So this is 2, 4, 6. And for letter D, this is 1, 3, 5. 1, 3, and 5. Again, in union, just simply copy all the elements or the possible outcome in both event. So we have here C union D is equal to 1, 2, 3, 4, 5, and 6. So that is our answer. Okay, let us continue. Number 3, I want you to try for number 3. D union E. And if you are done answering, you may now continue watching this video. Okay, let us check your work. So again, list down the given or the outcomes in event D. So we have 1, 3, 5. And then for letter E, 1 and 6. So D union E is equal to 1. So you see here that 1, we have here 1 for D and 1 for E, but you will write it once. And then 3, 5, and 6. And of course, do not forget this symbol, the brace symbol. Okay, so this is the answer. You got the correct answer? Very good. Number 4. I want you to answer number 4. B union D. If you are done answering, you may continue watching this video to check if your answer is correct. So B is equal to 3 and D is equal to 1, 3, and 5. So B union D is equal to 1. 3 appears twice, but you must write it once, and then 5. So this is our answer. B union D is equal to 1, 3, and 5. Again, do not forget to write this brace symbol. You got the correct answer? Great! How about last number, number 5, A union E? If you are done answering this number 5, you may now continue watching this video. So for letter A, the given is 1, 2, 3, 4, 5. And for letter E, this is 1 and 6. And the answer, A union E is equal to 1. You see here 1 appears twice, but you have to write it once. And then 2, 3, 4, 5, and then 6. So this is our final answer. You got it right? Very good. Let us try to solve this. Consider the situation below. Use your knowledge on probability in answering the questions that follow. So we have here number 1. A die is rolled once. Find the following. So we have here probability of 5. And the question here is probability that the number is greater than 4. And for letter C, the probability of odd number. So for number 1, what is the probability that when you rolled a die, the answer is 5 or you will get 5? So we all know that in a die, we have possible outcome of 1, 2, 3, 4, 5, and 6. So in letter A, the probability of 5 is 1 over 6. So you can see here again, when we roll a die, 5 may appear once, and they're over 6 because we have 6 possible outcomes when we roll a die. Same with probability that we may get number 2 when we roll a die. So 1 over 6. Probability that we may get 3 when we roll a die is also 1 over 6. So let's proceed to letter B, probability of number greater than 4. So this is, what are the numbers that are greater than 4 in a die? So these are 5 and 6, right? When we roll a die, the number which are greater than 4 are number 5 and 6 only. So the answer is 1, 2. 2 over 6 or 1/3. Okay, so for number or letter C, I want you to try to solve C, probability of odd number. And if you are done answering, you may continue watching this video. So the odd numbers, when we roll a die, so these are number 1, 3, and 5. So we have here probability of odd number. So we have 1, 2, 3. 3 over 6 or 1/2. You got it correct? Very good. Let's have another example. A card is drawn randomly from a deck of 52 cards. So we all know that in a deck of cards, we have 52 cards. So we have 13 pieces for flower, 13 pieces for spade, 13 pieces for diamond, and 13 pieces for heart. Find the probability of drawing the given card, an ace of heart. So, when we draw from a deck of cards, what is the probability that we may get an ace of heart? So, the first thing that you have to think about is how many ace of heart in a deck of cards. So, we only have one. So, this is the letter A, or the letter A and then heart, the heart figure in the card. So, we have only 1 over 52. The probability of an ace of heart is equal to 1 over 52. Same with an ace of spade. So we only have 1. So this is equal to 1 over 52. Same with an ace of flower. So we only have 1 over 52. Same with an ace of diamond. We only have 1 over 52. Okay? So next is a black face card. A black face card. So what is the probability that we may get a black face card? So it is 6 over 52 or 3 over 26. So how come that our answer is 6? Because we have 3 black face card for Jack. So I mean Jack, Queen, King of flower, and then we have Jack, Queen, King of spade. Again, Jack, King, Queen of flower, and then another black face card, Jack, King, Queen of spade. So we have 6 over 52, and then simplify, divide it by 2, so we have 3 over 26.